Hey everyone, welcome to our next panel. We've got a terrific panel for National Clean Energy Week, and the topic is going to be critical minerals, which has been a huge, huge issue lately. We've seen permitting reform, we've seen Defense Production Act, we've seen so many attempts to remedy this issue. And I know, Crest came out with a study showing that if we want to get the clean energy transition right, we've really got to address the minerals aspects as well. So I'm Philip Rosetti. I am going to be the moderator for this panel. We've got some excellent guests for us. We've got solar experts, we've got battery experts, we've got innovation experts, and they're going to be able to speak a lot better about themselves than I can. So I'm going to, go in turn here and introduce them and let them speak a little bit about themselves and their companies and their relevance to this issue. So Dan, why don't we start with you?
Oh, great. Well, thank you. So Dan Blondal, I am the CEO and founder of Nano Materials. We are a Canadian company developing industrial technology to improve the way cathode materials are made for lithium-ion batteries. It's a platform technology that we call our one-pot process, but it allows us to make a wide range of different cathode materials, so iron-based, nickel-based, manganese-based, and that serve virtually any kind of lithium-ion battery kind of application. As a technology company, we're developing IP, patents, know-how, engineering plans, et cetera. We have 24 patents issued in the US, in Canada, in Japan, Korea, Taiwan, China, and soon to be in Europe, and another 48 patents or so pending in various jurisdictions around the world. Our technology allows us, and this is where it kind of really fits into the critical mineral discussion we're having today. Our technology allows us to make lithium-ion battery cathode materials from critical minerals, but if using alternative sources of lithium, nickel, manganese, and cobalt. So that means we can, instead of using lithium hydroxide, we can use lithium carbonate. It removes one step in the supply chain. Instead of using nickel sulfate and manganese sulfate, we can go directly from nickel metal powder and manganese metal powder, for instance, and that eliminates a large environmental waste stream and byproduct that is actually quite a large volume of product, and it also eliminates complexity in the supply chain, reducing the number of steps. You don't have to go through that extra refining step. Obviously, it removes a huge amount of capital risk because we don't require that refining step to be in place. Most of these refineries don't exist yet in North America. However, the metal powders do exist, so it enables us to kind of really jump to the pump much faster. The technology really kind of allows us to leapfrog how it's currently done in China. We can't just copy the way cathode materials are made in China. First of all, they will, by the time we get it right, they'll of course had 4 or 5 years to get ahead of us. So what we really have to think about is how to leapfrog that technology. How do we do it in a cleaner way? How do we make a safe, secure, and reliable supply chain? And that's really fundamental to what we're doing at Nano One, reducing the cost, the complexity, and the environmental footprint of making cathode materials. Not just at the cathode manufacturing part of the supply chain, but also thinking very much upstream on how to improve that environmental footprint and how to get there faster. This, we believe, is a generational opportunity. We got to get it right this time because it will make a sticky, resilient, long-lasting supply chain that will be differentiable and competitive on a global landscape. Thank you very much. I'll pass it on to the others.
Yeah, thank you. We're really hoping that this technology comes through and helps to alleviate some of these issues. And Samantha, I'd like to turn it over to you and introduce your company and your involvement in the critical mineral space.
Sure, thanks, Phil. I'm Samantha Stone from First Solar. We are the only American headquartered company of solar manufacturers in the top 10 worldwide. We've recently announced our 4th factory to be built here in the US, which will bring us to 10 gigawatts of production domestically and 20 gigawatts worldwide. And hopefully there's a lot more of that in our near future. One of the things that sets us apart from the other solar manufacturers, in addition to our US footprint, is our semiconductor technology. We use something called cadmium telluride, CadTel. It has a theoretical efficiency of about 33%. So it's really, from a scientific perspective, one of the best possible semiconductors to convert sunlight into electricity. And as it goes with critical minerals, it's a perfect example of how, when we invest in the critical minerals capability here in the US, it feeds directly into the clean energy supply chain. Our cadmium is a byproduct of zinc mining, and tellurium is a byproduct of copper mining. And so today I want to make sure that it's understood that not just is it mining and processing and refining, but we also need the recovery so that those tailings can be put to good use, just as we're doing here. Just to extend the storyline of how these critical minerals flow through our product, at the end of life of our solar panels, on the other end of 35, 40 years of producing electricity in the sun, we can recycle them and recover about 90% of our semiconductor. And if you think about what I'm talking about a thin little deposition, about 3% the width of a human hair, that's sandwiched between two pieces of glass the size of a shower door. So it's a pretty novel technology for generating electricity. But not only do we recover it up to 90%, but then we can reuse it 41 times. And so that is, our great-grandchildren will be able to talk about what we've started here today with the same technology on the ground. Thanks, Phil.
Thank you, Samantha. That sounds awesome. And Alex, speaking of innovation, I think you guys deal with this a lot. So, please tell us a bit about what you do.
Sure. Yep. I'd be happy to. Thank you, Phil. First of all, thanks to Cress for putting together National Clean Energy Week, and thanks to you, Phil, for moderating this panel. I think it's going to be fantastic. So my name is Alex Fitzsimmons. I'm a senior director with ClearPath. ClearPath is a nonprofit organization that advances policies to accelerate breakthrough technology innovations to reduce CO2 emissions in the clean energy sector. And so I specifically work on renewable energy, energy storage, and clean energy supply chains, and critical minerals are a big part of that. Prior to my time at ClearPath, I served at the U.S. Department of Energy in a variety of roles. I had a large R&D portfolio that included critical mineral supply chains. So, that's why I'm really excited to be, here with you all today to be part of this panel. So thank you for having me.
Thank you. We're looking forward to diving into your expertise more because it's definitely going to be relevant here. Now, Jeremy, would you like to tell us a bit about your organization?
Sure. Hi, everyone. And want to echo my colleague. Thanks to Cress for making this event possible and for all the work that goes into it. My name is Jeremy Woodrum with the Solar Energy Industries Association. We're a trade association based in Washington, D.C., representing the solar and competitive storage industries. We have over 1,000 members. And actually, last week just had our big annual trade show in Anaheim, where we had 27,000 people all under one roof come together to talk about solar and storage in the U.S. It's now the largest energy trade show in North America. So a lot of excitement with sort of the legislative changes that have been happening. A lot of potential. People have shifted from the excitement to now addressing on the challenges that arise with any success as well. So that's definitely part of it. With respect to manufacturing, supply chain, and critical minerals, we have a manufacturing division comprised of many of the leading solar manufacturers in the U.S. and around the world. In addition to what Samantha said, and she flags some of the tellurium issues, the key component of a non-cadmium telluride PV panel is quartzite. And that is one of the most common elements in the world, actually, ready supply. It is mined here in the United States already. It is also, I guess you could say, transformed into metallurgical grade silicon in huge furnaces in Alabama, West Virginia, Ohio, and elsewhere, and then shipped to polysilicon plants similarly here in the United States in Tennessee, Michigan, and a facility that's going to reopen shortly in Washington State. So a lot of the supply chain we have here already, some of it's been mothballed until recently. So it's very exciting to see it opening again. We project that solar manufacturing, we've been projecting for some time now that solar manufacturing is going to take off, a real boom in the United States with passage of recent legislation. So that's now the case. So Samantha flagged one announcement there. There's a whole bunch of other ones that are coming as well, some of which have already been noted publicly, and some of which will become. So it's a very exciting time in the industry. Supply chains definitely are continue to be front of mind, but we're happy to have quite a bit of it here in the U.S. and we're looking to build out on that to achieve the rest of the supply chain as well. So thanks very much, and look forward to the Q&A.
Awesome, thank you for being here. And last but not least, we've got Jordan. So Jordan, please tell me a little bit about you guys.
Sure. Hi, everyone. And again, thanks, Crest, and everyone for putting this together. I'm Jordan Geist, Senior Director of Metals for East Penn Manufacturing. East Penn is the largest single-site privately held battery manufacturer in the world. We're headquartered in beautiful Lion Station, Pennsylvania, with a global footprint and a strong focus on high-performing quality products and environmental stewardship. I like to say we specialize in bottling up energy to provide our customers with a safe, reliable, economical, and highly sustainable source of energy to power their futures. And by the way, this source of energy, the lead battery, it's 99% recyclable at the end of its life. There's no other product in the world that even comes close in comparison. The North American lead battery industry leads the way for circular economies. It takes an innovative product that's designed for recycling, and then it partners that with probably the most established and robust infrastructures to not only collect and transport, but infinitely recycle these batteries at the end of their life in order to manufacture them into new batteries. It just doesn't get much better than that, folks. The lead battery powers everything from your vehicle at home. Yes, even those of you who have an electric vehicle, it has one in it, to forklifts, to wheelchairs, to energy storage and backup power for the grid and communications data centers, and much, much more. When we look at this clean energy transition, I think we can all agree there are a lot of challenges facing it, but there's also a lot of opportunities as well. We feel very strongly the North American lead battery industry is positioned rather nicely with an abundance of innovative, advanced battery projects underway and in the pipeline on the back of an already robust and ready to scale infrastructure to meet our clean energy needs. So I look forward, Phil, and the rest of my panel members to discussing this all further today.
Thank you, Jordan. We're definitely going to be diving into the recycling and all the exciting possibilities that has. So, for everyone tuning in, my hope is that I'm going to ask each of the panelists one question, and then we're going to open it up into other questions and try to get a more organic discussion going. And then we'll try to get some time for audience Q&A as well. We've only got, I think, another 45 minutes for this panel, and there's so much to cover. So I just want to dive right into this. And Alex, I've got the first question for you. You mentioned ClearPath, and you guys do so much on the energy policy space, the energy innovation space. So from your perspective, what happens if we don't get the critical minerals right? And what is this going to mean for energy innovation if we can't address supply chain issues?
Yeah, that's a great question, Phil. Thank you for that. I mean, I think in many ways, critical minerals are the linchpin of our clean energy future. I mean, if you look at IEA's net zero scenarios, they show that market demand for critical minerals like lithium, cobalt, nickel, graphite are projected to rise by 20 to 40 times, not 20 to 40%, 20 to 40 times in the coming decades. And so, we all want an energy system that's affordable, reliable, clean, and secure. And we've seen years of cost declines for lithium ion batteries, 90% cost reductions in just the last 10 years alone. Despite that, we've seen lithium prices rise by more than 6 times in just the last 2 years. And so if we don't get the critical minerals question right, then quite frankly, we don't have an energy future that's affordable or secure. But I mean, fortunately, I think there's a lot we can do. I think there's a lot that has been done. I mean, there's a ton of new policies that we're going to get into, everything from the bipartisan infrastructure law that included billions of dollars of scale up funding for battery supply chain projects, solar supply chain projects. I mean, there's also new tax incentives for production and investment of critical minerals. And then I think permitting is the next big challenge. The last panel, the last keynote got deep into the permitting issue. That's a huge challenge, and I see it as a bipartisan opportunity for the next Congress. And so I think to truly build a domestic supply chain for critical minerals, we need to marshal all of the resources that we now have in law and in policy towards 3 primary goals. That's investing in the upstream mining and crucially processing capabilities, which the US currently largely lacks. It's investing in reuse and recycling technologies, and then it's investing in substitutes. So everything from lowering the cobalt content of the cathode to, for example, using silicon to replace the graphite in anodes, which can increase the energy density of the batteries while also helping to mitigate some of these supply chain challenges that come with graphite. So all of these things, all of these policies need to be part of a comprehensive strategy. And I think it's such an exciting time to be working in that space, because I think we have a lot of the policies that are moving now.
Absolutely. And we're going to dive into the legislative developments a little later. But before we get to that, you mentioned this huge need for critical minerals. And, Dan, I think you'd probably be able to tell us a little bit more about the supply chain, how your company is trying to sort of overcome a lot of these supply chain issues that we keep hearing about. So why don't you tell us a little bit about that so some folks can really understand this?
Yeah, well, look, first of all, Alex summed it up really well. We have a wall of demand coming for raw material supplies, mining, refining, and everything that has to happen long before you assemble a battery. And really, there's a lot of sort of mining and refining and sort of capital risk associated with that. And we have to come together as an ecosystem, as a community to build that and build something that's kind of robust and strong. So where Nano One fits is the materials get mined that will typically get refined into some kind of a usable metal that will then be converted into a battery grade metal, and that's before it ever gets to a cathode. It often gets converted into an intermediate chemical like nickel sulfate. Or lithium hydroxide, and then that's met at a cathode producer who then combines them all to make a cathode material that's a composite of lithium, nickel, magnesium, cobalt, for instance, or lithium iron and phosphorus, which is a cobalt-free cathode material, and a variety of others. And the real where we fit is right there with the cathode materials that are assembled, and our ability to use alternative sources of nickel, magnesium, cobalt, as I mentioned during the introduction, allows us to drive complexity out of the supply chain, reduce some of the sort of the capital risk on plants that have yet to be built, and really target raw material supplies that actually are in existence today. They are here in North America, however. Unless we figure out a way to use them directly, like we're trying to do at Nano One, we're going to have to take on a whole bunch more risk, and pretty much all of that sulfate that's converted in the midstream will end up as a byproduct that goes into landfills and is either or has to be diluted and streamed or poured into the ocean, and we simply cannot tolerate kind of volumes of waste that are going to be produced in that supply chain. So it's an imperative to change it, not only from an environmental perspective and a cost and complexity perspective, but also really to help differentiate from the way it's done in Asia.
Awesome. I mean, I think the environmental challenges you touched upon are going to be huge. And, Jordan, I know your company really hammers home the recycling point. So, I'd love to hear a little bit more about you guys and how important you see recycling, materials reusability in the space, and and how much of a difference that can make?
Phil, that's an excellent question. We see it as a huge player in the future market here, and I think we must look no further than perhaps the greatest recycling success story of all time, being the lead battery, and the critical role recycling has played to ensure close to 90% of our major raw material for new batteries, being lead, is secured domestically. That's a huge win for national security, the environment, and for all of us. Think about this. Again, as I mentioned, in my opening, there is no other product in the world that you can manufacture and at the end of its life recycle 99% of it to make a new product. We are not talking cradle to grave here. We are literally talking true circular economy, cradle to cradle. Is this not the holy grail of sustainability for us? I remember back to the old Gatorade commercials of the 90s with Michael Jordan, and everybody was, I want to be like Mike, where everyone wanted to be like Mike. Should we not be applying that same mindset to all new technologies, in that they want to be like Mike and emulate lead battery recycling, where we are creating a sustainable product designed to recycle up front? I think the true circular economy model of lead batteries, it definitely promotes sustainable management of our natural resources. It decouples growth from those same resources, and it ultimately protects our national security interests. By recycling these lead batteries, we're also able to produce new batteries with 90% less energy and produce 90% less greenhouse gas. I think perhaps recycling, now more than ever before, will be a critical component in securing our domestic supply chains. And we need to take advantage of the established infrastructure in place today to scale as fast as we can to create an environment that incentivizes and invests in safe, environmentally sound recycling practices domestically. And I highlight domestically because that is key. If not, we're just going to allow all these precious critical minerals to leave our borders without being able to replace them. And countries like China will reap the benefits, placing our national security at serious risk. And on top of that, most of the time, these minerals are recycled in countries with informal, less than desirable recycling practices, creating further adverse environmental and social problems. Recycling of our critical minerals just may be one of the greatest solutions we have to remain a dominant leader in this world today.
Well, thank you. And I think, touching upon those supply chain issues and kind of the domestic versus foreign aspects leads very nicely into my next question, which is going to be for Samantha. As an American solar company, what are some of the unique supply chain challenges that you guys face? Because I imagine it's a lot different from, Chinese solar manufacturing, which is, the bulk of a lot of the global solar scene.
Today, but if we do it right, Phil, that's not going to be the same story in 3, 4, 5 years. It's a good question, and I'll go back to the mining part of the story here and echoes what Dan had just talked about, and Jordan as well. If you start with our technology, our CAD-TEL solution to convert sunlight into electricity, the tellurium, as I mentioned, is a byproduct of copper, but today, half of the world's copper refining occurs in China. And so for us to think about America's solar workers extending all the way back to mining, we need to think about how to take the storyline that Jordan just gave us and think about the sustainability and circularity all the way back at mining. We work very closely with Rio Tinto, and they just opened earlier this year a new copper refining facility at their Kennecott facility in Utah, for which they are recovering tellurium that benefits us. But the Kennecott facilities only can serve about 7% of the U.S. copper demand. They've got their other project, subject to permitting still in Arizona, the Resolution Mine, that once online and operational can provide about 20% of the US copper demand. And so there's a permitting solution here that will help supply chains, but there's also thinking about the recovery of these tailings to feed the circularity in the mining. And I'll use an example in the battery space. Lithium is its own primary mined material. However, it can also be a recovered material from boron mines. And so the more we start thinking about the connectivity between what we can recover in tailings and how that also can benefit us, the better we are able to supply the supply chains that will benefit, but also build on the sustainability story and, frankly, the revenue streams of some of these mines in order to ensure that the cradle-to-cradle concept that Jordan just introduced carries through across the entire clean energy sector.
Fascinating. This is, certainly an exciting time to be involved in this space. And you mentioned, China controls so many of these supply chains currently, hopefully not always, but I think that's a great topic for Jeremy to cover. I mean, your organization represents so many solar industry, participants. How are they thinking about these supply chains, and are they concerned about these, potential disruptions from Chinese supply or whatnot? Or do they prefer more U.S. supply? Tell us a little bit about what they're thinking.
Yeah, for sure. I mean, I think like many industries, I think have been looking to diversify since COVID, and sort of other supply chain problems, and ensure there's multiple sources of their products, but also build up a domestic industry as well. I can say the challenge for U.S. developers right now is U.S. solar is sold out. There's none available for multiple years. So you want to get it, you can't get it. But that's leading, the good side of that story is that's leading manufacturers to invest here in the United States because they see the incredible opportunity here. So as I mentioned earlier, I think we're going to see at least 20 to 25 gigawatts of domestic solar manufacturing come on here pretty quickly in the next year or two, especially if we're looking at sort of solar panel manufacturing. We already have a lot of polysilicon production and metallurgical grade silicon production. The middle points of cells and wafers are something that are going to be stood up as well. So it's just an incredibly exciting time in the industry. And yeah, it's part of it is because you want to have diversity in supply, and you also want to have assuredness of supply. And so you can't build a solar, you can't build a solar power plant if you don't have the materials and supplies. But that's leading sort of add-on industries as well to invest further here in the United States. The average, so let's just say take an average, utility scale solar farm, maybe 300 megawatts. That uses 12,000 tons of steel, a lot, and that's going to be American steel. Those are folks that produce here, sort of across the Midwest. And elsewhere, and they're expanding their own facilities here now and signing new contracts to be able to finance the build out of the industry. So it sort of goes beyond the panel. We're also going to be seeing inbound investments in inverters, which is a sort of key part of any solar plant, and in trackers as well. So kind of everything is happening. I agree with Samantha, where the industry is not going to look the same in 2 to 3 years as it does today. At all for the reasons you identified.
Oh, that sounds great. So now I want to ask questions that are going to be more directed towards all of you. For Isa, I'll probably pick out one of you to answer first. But I want this to be kind of an interesting discussion. Anyone has thoughts on these, happy to hear them. So I think the question that all of us want to know is, what are you all thinking about the Inflation Reduction Act? How is this going to change the space? It's chock full of energy subsidies. It addresses a lot of issues, and there's supposed to be a sidecar deal for the permitting now, and the congressional resolution, or sorry, continuing resolution. And Alex, you've worked on this stuff so much. I'd love to hear your thoughts. What difference does the IRA make, and where does it fall short? What should we be thinking about for other energy legislation?
Sure. Yeah, that's a great question. Thanks, Phil. First, I'll say that the partisan process for reconciliation is unfortunate because the issue of critical minerals has largely been bipartisan. And so I think it's important to view reconciliation in context because we don't get to that bill without the other bills that came before it. So, for example, the bipartisan landmark Energy Act of 2020 included, several important authorizations for critical minerals that were then funded and expanded by the bipartisan infrastructure law, including a tremendous amount of scale-up demonstration scale funding. One small piece that's also overlooked in the infrastructure law is that it requires the Interior Department to develop a performance metric to measure its progress on permitting for critical minerals. So that's an important piece that I think will be important for oversight as we look to the future. Then, the DOE Loan Programs Office was already looking at critical mineral projects from a finance standpoint in the previous administration, and now they have expanded loan authority, so that's a good thing. And then, of course, now we have all of these new tax incentives in place on the production and investment side. So all of these pieces of policy have an impact, and you don't get to where we are today without the bipartisan foundation that's been laid over the last few years.
Fascinating. So I'm sure everyone else got more insight on that. I can call on people, or if you want to go, let me know. But I think Samantha, that you've got something to add. So let's turn it over to you next.
I just really love Alex's point about the unfortunate nature of IRA being viewed as a partisan bill, because he's so right. The value that this is going to deliver is bipartisan. And if you think about just the job creation, we're talking, I'll use our factory that we just announced, our fourth in the U.S. That brings us to 3,000 jobs direct, and a total direct, indirect about 18,000, and that's just one facility. And we also bring our supply chain with us when we come. So there will be more glass float in the country as a result. And then we get soda ash from Wyoming. And the extent of what IRA is going to allow this sector to do is not just address climate change, but we're talking American jobs, American manufacturing, up and down the value chain. The fact that critical minerals has its own set of manufacturing and production incentives just speaks to the importance of thinking about what we're doing here in the most bipartisan way we can.
Fascinating. And Dan, I know that your company probably is looking at this, and you're Canadian company, so you guys probably have a different perspective on how do these things affect not just American policies, American supply chains, but global demand and global aspects. So what do you think of the IRA and these potential other policies that could be pursued?
Well, look, no single nation or single company can do this alone. We're trying to change the supply chain. We're trying to, it has to be kind of an ecosystem that comes together. So we need to build that ecosystem of like-minded nations and companies and, refiners and chemical producers. We need to do it with clean energy, environmental standards, advanced manufacturing. All of this is going to be really key to establishing a long, sustainable supply chain. And really, the IRA and the Defense Production Act are two policies that have that recognize the need to expand really beyond the borders in the U.S. To bring in friendly nations and like-minded companies to kind of to tackle this problem. The one thing that I think really impacted our business is with the IRA is overnight it changed. It basically put the EV tax credits on the line. If you don't have what I can't remember what the number is, but 40, 50, 60% friendly sourced materials in the batteries, you don't get the EV tax credit, and that literally changed the perspective from the auto manufacturers overnight. They can no longer rely on China to meet the short-term demands to stuff batteries between the wheels because it's not going to they're going to lose their tax credit. So that sent everyone scrambling to try and figure out how are we going to do this in North America. How are we going to do it from sources that are there, and what are we going to need to build to make it happen. So it's had a tremendous impact for us, for our business, certainly for the positive. I think it's really brought what we have in Canada and what there is in other nations around the world to bear on this problem. It's going to be extremely important that we figure out how to work together on this with this policy, and how to drive these critical minerals, which of course are where they are in the world. We can't wish them out of the ground. They are where they are, and we have to find ways to extract them, process them as locally as possible before we start shipping them and stuffing them into batteries. And that's going to be really critical. We believe that central Canada would be largely in the what you would see as the east, so Ontario and Quebec and even into the Maritimes will be really a center of gravity for battery materials from a mining, refining, and cathode material space, and that will then feed into the North American battery and EV market and energy storage market as well.
All right, so we'll cooperate on batteries, and hockey, it's a fair game. But
Yes.
I think absolutely, and Jeremy, you represent so many different members across these issues, and I imagine they've got a lot of impacts and thoughts about the IRA. So tell us how it's changing things in your space.
Yeah, in many ways. I mentioned some of the stuff on the manufacturing front and the coming manufacturing boom. I know the Secretary of Energy often says deploy, 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 and we fully embrace that. Also, probably add mine to that too, or mining. It's going to be, I think, probably everyone here thinks that's an essential a part of this additionally. And the incentives are there in the bill to make it happen. I guess a couple things I'd flag. Number one, there is incentives for use of domestic content. The developers who are part of SIA are seeking that. And so they are asking their manufacturers to find a way to make it work, to make it here in the United States. Across the board, it's a valuable, important additional incentive. And so it's having a big impact. I'd say that just when that provision sort of first came out last, I guess it's really been over a year now, year and a half, it already started happening. Developers saw sort of this was a potential on the timeline and started asking the manufacturers, hey, show me how we get from A to Z on this so we can meet this standard. That's playing a big role in the rewrite. I think another piece, placement of projects is probably going to be more fully developed. There's incentives to place projects in distressed communities, in former energy communities, or places where a coal plant has changed, in low income communities. So people are going to be thinking carefully about whether they can get an higher incentive level by placing projects in those areas as well. And then there's labor provisions as well. To get a higher credit rate, you have to be paying prevailing wages and apprenticeship. So all these things are changes that the industry is working on digesting right now, everybody in different ways. But on the whole, a really positive step forward.
All right. Thank you. And Jordan, any closing thoughts on the IRA before we move on to the next topic?
Yeah, I think honestly, I think the jury's still out on it a little bit. I think when I look at the infrastructure and reliable power generation we have in place today, I kind of question if we're anywhere close to being ready for our growing energy demands here today, let alone the future. If we move too fast on all the things that we plug into the grid, without all of that infrastructure and reliable power generation to support it, I wonder if does the entire country start to resemble more of what's going on in California with sky high electric prices that are double that, mind you, of the rest of the country, and constant energy curtailments to combat their shortage of energy needs. And that's on everything from when you plug in your electric car to how low you can program your air conditioner. So I wonder if this is truly progress for us, or should we become more diligent a little bit in where these investments are going and the pace at which we are transitioning to ensure this transition is truly sustainable for us. I think it's more of a marathon than a sprint. In the IRA specifically, we do like the fact there is a a very strong emphasis toward domestic sourcing. There's investments in recycling and advanced next generation lead batteries, along with a diverse list of other technologies. Because I think as everybody mentioned here, I think we can all agree that no single technology country will be the silver bullet here to power our needs into the future. And it's definitely going to take a multitude of technologies to get us there.
Fascinating. Yeah, definitely an interesting perspective. And, I see that I've got like this timer in front of me, and it shows that we've got a limited amount of time. So I definitely want to touch on one other big topic, which is going to be the war in Ukraine. How this is affecting kind of considerations of supply chains. Are people concerned about not just Ukraine, but okay, is this speaking to potential risks with Chinese controlled supply chains? Are we concerned about adversarial foreign powers that can influence access to minerals for future energy needs in the past way that we've seen it with fossil fuels in the 70s and the oil embargo. So, I'd love to hear kind of your thoughts like, okay, what does this sort of current political dynamic mean? How are, policymakers, how should they be thinking about this stuff and addressing these potential risks? And, what are the solutions? What can we do about that? So, you know, Samantha, I think, you've got an American energy company, so why don't we let you start with that?
Sure. I think it's been very concerning watching what's going on in Europe, and the coming winter is going to be a hearkening moment for so much of the globe. We just wish we could empower a transition a little bit faster. The thing that we take away from the war is exactly what you alluded to, Phil. When we have an overall dependency on an adversarial nation, we lose control of the security of our supply chains. And in the energy space, energy security is one of the most important things our generation and future generations are going to need to protect. And so Jeremy, I'm sure, and his team is very familiar with what we have been trying to do to ensure that it is well understood how over reliant solar has been on other nations, and in many cases adversarial nations. Just to give you an example, and Jeremy did highlight that IRA is going to give us a chance to change this, but 95% of the wafers used in solar are made in China. And as we think about Russia's hold on energy across Europe, that's not particularly different as we think about China's control on fundamental components of solar space, of the battery space, of the EV space. We would really be in trouble if we moved from an OPEC controlled world to a single nation controlled world for our energy future.
Very well put. Absolutely. Jeremy, you were referenced a lot there as having some insight to offer on this, so let's turn it over to you next.
Oh, sure. Yeah, no, that is the case. And that's why a few years ago we kind of did a deep dive on this issue, released a white paper, worked with others to come up with a plan to build out a stronger domestic manufacturing base, including in cells and wafers. Talked to a bunch of companies, got feedback, and rallied to get this stuff in the bill. So now we just got to make sure it happens. And from the announcements that we know are coming from companies, we're really excited that it's going to. So yeah, it is the case that both on the developer end and the manufacturer end, people are looking for more diversity in the supply chains. It's been the case for a while now. Now we just have kind of 10 years of policy certainty to make sure it happens. I mean, we're always going to want to be able to work with other countries and such. I know there's some friends from Canada here who are on the line, and I think all solar companies import to some extent, but we do want to build up. Our goal is to have 50 gigawatts of domestic manufacturing across the entire of every piece of the supply chain. That's 2.5 times what was installed last year. So we're folks are looking to go big, and those who go first are going to reap the rewards.
Absolutely. And, Dan, you were referenced there. So I'd love to hear your thoughts because I think you've already alluded to it, this importance of having kind of a friend shoring of some of our production and, a more amicable supply chain where there's true competition and freedom of investment and movement.
Well, the obviously what's happening in the Ukraine is terrible. I mean, on so many fronts. One of the things that that's kind of happened in our space almost immediately, of course, the sanctions against Russia have an impact on the supply, for instance, of lithium hydroxide. So a good chunk of the world's lithium ends up going through Russia to be converted into lithium hydroxide because we don't have the facilities here. So it's put a constraint, bottleneck on it. Same thing goes with nickel. Nornickel in Russia is one of the largest nickel producers. So these have definitely put real constraints on it. One thing we have seen very overtly is the Europeans coming to North America, looking to build relationships and actually, as you say, friendshore their supply chains, looking to Canada and the U.S. For these critical minerals for batteries. Just a couple of weeks ago, I spent a couple of days in Montreal and Toronto with the largest foreign delegation that has come to Canada in a generation from Germany. So Germany's largest sort of automotive manufacturers, their energy, all the people sort of controlling energy and gas imports, were all came into Canada to basically to establish a stronger relationship. A number of MOUs resulted from that, and of course it's around batteries, it's around access to gas, it's about access to hydrogen. All of these are playing really sort of a critical role. And a couple of years ago we weren't seeing that. Obviously, what's happening in Europe is having a really big impact on that. So that's just to give you kind of an example how we're seeing the impact of that reverberating around the world. And again, to our advantage, we're seen as a friendly nation. We're very like-minded. I think being able to bridge that with the U.S., with Germany, with other nations around the world is going to play a really sort of important role on that. I want to just touch on one thing, and this is maybe some common ground with Samantha. We're also partnered with Rio Tinto. They actually took an equity investment in Nano One back in June, and we're working with them on lithium supply and iron powder supply. The facility you mentioned, they have a boron mining facility in the U.S. where they are recovering lithium from the tailings. So we are working with them on that front. But also, they are the largest producer of iron powders in the world in a facility in Quebec, just about 1 hour north of a facility that we're currently acquiring. It will be the only lithium iron phosphate manufacturing facility in North America. We're about to acquire that in the coming quarter. We should close on that, and just an hour north of that facility is the largest iron powder producer. If we can go directly from those powders, and that's kind of all part of the arrangement we have with them, we'll be able to go from iron ore to melt to atomized iron powder to lithium iron phosphate and into a battery with zero waste stream, and all done on hydroelectric power. So probably the greenest, cleanest supply chain in the world. There's a lot of work to be done there, but I think that's what I want to bring that up as an example of how we can actually come together with the miners and establish something that's highly differentiated from the way it's done in Asia, and to bring something that I think is very attractive not only to the North American market, but will also be very much so for the Europeans.
That's an excellent point. I think as important as this is for us in America, I think the Europeans are probably even more concerned about it than we are. So we're very tight on time, but I just want to give both Jordan and Alex a quick chance to respond to that. So Jordan, why don't we start with you, and then we'll turn it over to Alex on this kind of foreign policy dynamic.
Sure. Those were all great points made. I think should we be making investments in America and our strong allied partners today to safely and responsibly source, this plethora of critical materials? I think we would all agree and say yes, definitely, as much as we can. I think when we look at countries like China, I would argue we are well behind the 8 ball in terms of sourcing raw materials, both domestically as well as, creating the infrastructure and the manufacturing capabilities to support our energy needs for the future. They laid out there, China dominates on the world stage in what we call all of these clean tech energy minerals for electric vehicles, solar panels, wind turbines, the coppers of the world, nickel, cobalt, lithium. From production to processing, China owns the majority of it. I saw a stat, by 2025, China would control 75% of the global raw materials for lithium ion batteries. And to the note on global solar panel manufacturing capacity, they control over 84% of it. This pins the rest of the world to a strong reliance or dependence on China. And I want to make clear here, it's a country that does not align with our values and is far from our friends, folks. And if there's anything I think that we've learned or should have learned from COVID and the Ukraine war disruptions here is that, should it not be that we are seriously rethinking our supply chains to be more robust, more reliable, and with strong partners that align with us. And again, this is something, I think the lead battery industry here in North America has worked very hard at, as close to 90% of lead batteries sold in North America are manufactured with North American recycled lead. That's a big win for all of us.
All right, so we're super tight on time. So Alex, I'm going to ask, lightning quick. Any closing thoughts on that?
Yeah. Sure. Yeah. Just very quickly. I won't rehash all the great comments. I'll just add, we do not want to trade our relative fuel security for mineral insecurity. And recent events have added a new dimension. It's really been a paradigm shift. I mean, we can no longer think about energy as just being affordable, reliable, and clean. It now also must be secure. And that's a market change. And I think it's ultimately one for the better.
Fascinating. That was like a perfect bulleted talking point. So I want to get into some of the questions I've got from the audience here. If you see me kind of looking over, it's because
You didn't give me much time, so I had to do it.
Hey, it was perfect. I knew that you could do it, so that's why I call on you. But we've actually got like a voting system here for our question. So the top rated question right now, this is going to be, I think, an interesting one for Jordan. So it says, can you explain how the circular infrastructure works for lead batteries and how this could apply to other battery and clean energy technologies to ensure we have the critical minerals we need domestically?
Sure. Yeah, great question. I think I'll be cognizant of time here. The North American lead battery industry, has a robust closed loop supply chain that ensures, our feedstock for lead batteries remains available and protected from these global disruptions. There are over 50 manufacturing facilities in North America, supporting over 92,000 good paying U.S. jobs with an overall impact of, economic impact of $26 billion. As I mentioned before, the lead battery is the greatest recycling success story of all time. We employ a highly efficient recovery process, operating, to some of the world's most stringent environmental standards to ensure the highest level of environmental protections, all in an effort to infinitely recycle 99% of lead battery without sacrificing quality or performance to produce these new lead batteries. And we do that, 130 million times a year. This allows us, to source 90% of our North American battery needs domestically, reduce our reliance on, foreign suppliers while slashing energy consumption and greenhouse gases. Again, without this, this precious resource would leave our shores without us having the ability to replace it and pose a grave risk to our security. As Alex mentioned there, and more than often these batteries are sent to lower environmental and health protection standards, countries with those. So we are protecting communities everywhere through this closed loop circular economy model. Is this not what we should all aspire to as we build products and technologies, to support the clean energy needs of the future? I think so.
And we've got a little bit, but there's one other really good question, which I think both Samantha and Dan probably have really great insights on. So this question here, it says, the current grid system as we know it is 140 years old, a vestige of the Industrial Revolution. The future of energy will be increasingly decentralized, devolved from the command and control grid system. What potential do you see for distributed energy and microgrids to decarbonize and fortify the main grid? So why don't we start with you, Samantha?
Sure, I think that's a big part of the future. The heat wave in California not too long ago is crediting the distributed nature of solar as one of the reasons why there were no rolling blackouts in California, because there is a role that solar and solar plus storage play in providing a faster alternative to ramping up and down traditional sources of energy. I think there's microgrid roles. I think there are community solar roles to play. And we also can't overlook the importance of expanding and upgrading the grid at its core, which is also part of the infrastructure bill that passed recently. So there's transmission expansion, there's grid investment, the interconnect upgrades. All of this has a role to play.
Absolutely. And Dan, I imagine you probably have some thoughts on that as well.
Yeah, look, I think Samantha covered it mostly, but batteries are going to be key to that, and all types of batteries, not just lithium-ion batteries. And there's vanadium redox flow batteries, and there's all kinds of energy storage that address different needs. Whether you have to store energy for seconds, minutes, hours, days, months. Every one of those are going to be absolutely critical to us having a decentralized grid that can address the needs that Samantha was talking about. If you don't mind, I want to just jump in on the what Jordan was talking about on the recycling front, and I think it's really important to understand recycling is always going to be incredibly important for lithium-ion batteries as well. But we're a long way off. I mean, we're really in the infancy of lithium-ion batteries. There isn't a critical mass. There isn't a mountain of batteries out there yet to mine, and the average battery in an electric vehicle has a warranty of 8 years and a lifetime expectancy of 16 years. So, and double that till we actually have a critical mass. I mean, we are 20, 30 years away from having a really complete circular economy in lithium-ion batteries. We've got a lot of time to figure it out, but we have to do it right, and we have to do it without waste streams, and we have to do it in an environmentally sensitive way.
Absolutely. I think the battery replacement aspects are not fully appreciated in some of the studies and projections we have. There's just kind of an assumption that we're going to do it, it's going to be easy, and we haven't got the full solutions yet. So, we've got basically a minute and a half left. So I want to just let our panelists know if you got closing 20-second remark, and Alex, I gave you so little time. So I'm just going to say, if you want to, wrap up a 20-second comment, you can. And anyone else, please let me know.
Sure. Yeah. Happy to, Bill. So look, I think there's a lot that we talked about there. We could have spent hours more talking about these various things. I think it's important to recognize that we have the innovation policies largely in place, the scale up opportunities, the market incentives. Now we need effective oversight of those programs, and we need to build on that with meaningful permitting reform. I mean, none of what we have done matters if we don't get the permitting processes right, so that we can build cleaner energy faster.
Absolutely. And Jeremy, I think we didn't hear as much from you, so I'll give you another 20 seconds if you want to chime in with a closing thought.
Oh, just that it's the recent bills are exciting it's not just solar, across the industry. I know the modular nuke folks are excited, nuclear is excited, solar is excited, hydrogen, carbon capture. It's a broad range of folks that are looking. We're going to see big time energy investments here in the coming couple of years.
Absolutely. Well, thank you all for being here, and thank you for joining us. Thank you to Crest for hosting this, and I hope all our listeners were able to learn something about critical minerals and supply chains and clean energy. So thank you for joining us.